The agenda of this session is an introduction to big data and Hadoop. We'll also understand big data is a very, very wide term. We'll try to understand what does it mean to all of you, depending upon your background. Say, for example, if you're a developer, what does big data mean to you? If you're a test engineer, what does that mean to you? If you're an analyst, if you're a project manager, so what does actually what is there which lies in for you there? Let me start with the agenda for this session. I'll also introduce you to the edureka website in a while, but let me start with a in the introduction to what are we going to come up with in this session. What should be your expectation from this session? So by the end of this session, I think what I'll try to answer first of all is what are the various learning paths in big data, depending upon your job role and the kind of where do you want to go, right? So what should you learn in big data depending upon your current experience, your career growth, right? So that will be the first part of this session. I'll go on to introduce what does actually big data mean. There are a lot of misnomers, there are a lot of myths around it, so I'll try to clarify as much as I can. Then we'll talk about Hadoop and its ecosystem. Don't worry what Hadoop is at this point of time. I'm sure by the end of this session you'll understand Hadoop very well. Now I'll start with the uh, very basic, right? How does the course work, right? So a typical online course at edureka, right, consists of not just the live classes like the one you are having here. It is a combination of a lot of things. So the way it works is that you register for a course, right? You get all the your course content, your recordings, your installation guides, the labs, everything is available in your learning management system, right? And then you attend these live sessions which are scheduled, right? I mean, through this tool itself, go to webinar. In the live session, you it's an interactive session. You can ask questions from the instructor, you can clarify your doubts. After this session, these sessions are recorded and you get the recordings of your session in the learning management system. I'll show you a view of that as well towards the end of this session. uh, and then post the class, right? Now that you've attended a class, if you have questions, doubt, queries, there's a 24/7 day and night support available. So you can just log in a support ticket from your learning management system. An engineer will be assigned to work on that, and they'll be happy to help you out with anything over email, or even a one-to-one help is available. Say in case you are stuck with some installation, you're stuck with some code debug, the team can help you out, right? So that's how it works, the support works. Now then for every course you have module wise quizzes, assignments you have which you have to take after every class to reinforce your understanding. If you are not able to answer something, you can get help. And then once you're done with the complete course schedule, you at the end of the course, you if it's a tech course, you have to do a project, right? Where you can where, say for example, in this big data course, there'll be multiple data sets from various domains which will be available in your learning management system, and you will pick up one of those or multiple of those, and you'll do a project around that. That project will be evaluated by our instruction panel, which again consists of people from the industry who are experts in this domain. And based on that, you will be given a review on that project as well as a graded certificate. This certificate will be available online, and this will be you can always refer to this when you are showing it to your company, right? So that's how the overall course works. If you are a developer and you're looking to get into the big data world, right, there what you need to do, I mean, what you need to learn, right? The skills which you'll require will be either of these programming languages. It could be Java, Python, Ruby, right? It could be Perl as well, right? I mean, there are a lot of languages supported. By default, I think Hadoop is language agnostic, but then it's written in Java. So a lot of MapReduce design is done in Java and Python. But if you're comfortable with any of these languages, you should be good to go. You should understand the Hadoop ecosystem, which means the various tools which are a part of the Hadoop ecosystem. I'll get to that in a while. Then you should, as a big data developer, it will be expected out of you that you should be conversant with at least one of the NoSQL DBs, right? Which is either a Cassandra, a MongoDB, right, or any other NoSQL DB. And then Spark is something which is an in-memory DB in Hadoop. I'll talk about that also in a while. So this typically is your learning path if you are a developer. So these are the technologies you should be conversant in. Not now you need not learn everything in one go. You can take your time, but if you know these things, then you will be considered a good uh, you will be considered a person who can work on a big data project as a developer. Okay. Now coming to the administration part. So typically there are three learning paths in big data, right? There's a developer part, there's an admin part, and then there's a data analyst part. So if you're a administrator, if you come from either a DBA background or a Linux administration background, the expectations in the skill sets will be you should be conversant with the Linux administration. You will understand the Hadoop cluster setup and management. You will also be responsible for cluster performance and virtualization, right? So those are the things which you will be responsible for. And for that, I mean, two skills which edureka has multiple courses on big data, right? I mean, we'll probably have the largest catalog of big data courses. For a administrator, these are the courses. If you are already know Linux administration, you can directly jump to Hadoop administration. If you're not aware of Linux administration, it is advisable that you should learn a little bit about Linux administration before moving into Hadoop administration. Okay. Now, coming to the next path, which is a data analyst part, right? So a data analyst in Hadoop is actually the person who will be analyzing the data, uh, drawing meaningful insights out of that data. Maybe say for example, if you have a retail data and you want to find out the customer churn and maybe figure out what is the best way of reducing the customer churn. Churn, by the way, for the people who do not know, means that if I have say 100,000 subscribers every month, how many are dropping off, right? So that's the customer churn. So if you have to do that kind of analysis, that's the role of a data analyst. You need to understand you should have a good understanding of some of the statistical analysis. You'll have to learn some machine learning algorithms. You also need to understand big data in terms of Hadoop, right? Because ultimately, though you will not be writing programs in Hadoop, but you'll still be using Hadoop. You may be using you should have expertise in R. So R basically is a language which is used by most analysts for big data analytics, and it sits on top of Hadoop if required, and you can do a lot of statistical analysis on top of it, right? And then you need to have a good handle on some of the data visualization tools. So R also gives you a lot of data visualization options. And then there's a tool called Tableau, which I recommend. Usually you can use any other visualization tool as well, but that's the tool which I usually recommend. Okay. Rishabh is saying that what is the scope of testing in big data and Hadoop? Okay, so good question, Rishabh. So what I usually suggest is that, I mean, there are it is more like so there'll be in Hadoop also you will be writing your MapReduce program. So there's something called a MR unit using which you do your unit tests there. So that part is covered in the big data and Hadoop course, right? And as wherever there is a requirement for developers, there's obviously a requirement for people who will be doing the QA or the testing. So yes, there is a lot of scope for people who come from the testing background as well. The typical learning path for testers is all remains the same. You may not want to learn say MapReduce design patterns as such, but then having a good understanding of Hadoop ecosystem, having a good handle on writing tests around Hadoop, which will be covered in the big data and Hadoop course, and then knowing say Spark, which is the new in-memory DB there, and knowing a good having learning one of the NoSQL DBs. I mean, mentioned Cassandra here, but you can as well learn MongoDB. So typically that's how it is. Okay, so I have a question which says that, okay, I have 10 years experience. I want to get into the analyst path. So what is the scope for me? Okay, so see, if you want to get into the big data analyst role, right? One thing which you need to understand is that analyst should have a good knowledge of the domain which you will be getting into, because more than the tech, the domain becomes very important. So say for example, if you come from a healthcare, you come from a, I mean, finance, or you come from uh, a retail domain, right? Then there are a lot of domains. I mean, these days there'll be a lot of unstructured data which you will be getting, all these chat records and everything, and you'll be doing a lot of analysis on top of it, right? So there is a lot of work which can be done in Hadoop, and So if you need to have a good understanding of the domain, and then there are tools available. R is the foremost tool which analysts use, right? Other than that, in the Hadoop ecosystem, there are tools like Hive, Pig, which are also used by the analysts, right? So how much time it takes to learn data analyst? Okay, see, the time is typically dependent upon the skills you have and how much time you're ready to put in, right? I typically recommend, if you are starting from a beginner level, I typically recommend, don't rush. At least take 2-3 months, right? Uh, Give yourself 2-3 months, because not just learning the tools, you need to learn a lot of use cases. You need to try out a lot of use cases from various industries to get the feel of what algorithms have to be applied. Now, if you're a data analyst, you need to understand the kind of analysis you'll be doing. So you'll be doing some clustering analysis. You may be working on some customer segmentation kind of analysis, which is the classification algorithms. So there are various statistical analysis which you need to do. You need to learn that. Then you need to master the language R. You need to get a good hands-on on Hadoop as well. How to connect Hadoop with R is something which is there. So, and then you need to learn a little bit of data visualization, because finally what an analyst has to do is gain insights from that data, right? So typically I'll suggest take at least 2-3 months, given the fact that all of you are working and you're not going to be learning full time. Okay, I hope this answers your question. Now there's a question: I'm currently working in virtualization support and looking forward to the development route. Okay, so I will suggest, my suggestion will be that getting into the administration path will be very good. Now it's a very, very in demand thing right now. There'll be a lot of requirements in your own company for that, and I have seen people working across various companies who've moved from support to administration role. So I will suggest that this will be the best path for you. So learn a little bit of Linux and then move on to Hadoop administration. Okay, then there is a question: how old is the big data and Hadoop technology, and what are its future prospects? Some top companies based on this technology. Good question. I think it's pretty old. You may not have heard about it uh, in the older days, but it's pretty old. It started with Google, probably in 2003-4. That was the time duration when they were doing their page ranking algorithm, and when they were getting huge amount of data. That's where it all started. But then in the recent past, right, Hadoop is the framework which actually made it available to everyone. It's an open source framework, so a lot of companies are now using it. A lot of companies in the domain of finance, wherever there is a huge amount of unstructured data flowing in, Hadoop is used. I'll go into some of the use cases as well as we progress in this session, right? How difficult is it to set up dev environment for development and testing? Can it be done in a single machine with basic configuration? Well, though I'll cover this at the end of this session, but I'll quickly give you a sneak view into this. So now, if you're a developer, if you're trying to do development in Hadoop, you can do it on a single node cluster as well. Okay, I'll talk about what a cluster is. Don't get confused there. You can do it in a single node cluster, or everything which works in a single node cluster will work on a multi-node cluster as well. But then in a real production environment, typically they will be ranging from 8 node to say thousands of node of clusters. Hadoop clusters can be found, right? It's not very difficult to set up. I mean, if you look at the course here, we help you set up the cluster. It's actually very simple. It's not too difficult. There are guides available. You can follow that. You can even set up a cluster on your laptop. If you have at least a 4 GB RAM, a single node cluster can be set up. If you have a 8 GB RAM, you can set up a multi-node cluster as well in a virtualization kind of mode. Then but if you're looking to, typically what companies do, the large clusters are set up either on public clouds or private clouds, and that also remains the same. I mean, there's an instruction in this course itself where we teach you how to set up a cluster on Amazon cloud, the AWS. So it's not very difficult. Just need to follow the instructions. Okay, so there is a question on machine learning, right? So see, yes, machine learning forms a very, very important part of if you're looking at a data scientist kind of role, which actually is I'm talking, when I say data analyst and data scientist, I'm talking in general about that. So as a data scientist, what you need to do is that you have a huge amount of data maybe stored across clusters, and that data is coming in. Say for example, look at any e-commerce website, right? Huge amount of customer data coming in on a hourly basis, and you need to gain insights. You need to make decisions based on that okay, if this is the kind of customer coming in, these are the offers to be shown to them, right? Say for example, I'm sure everyone has seen Amazon or a Flipkart, where you see these are the products recommended for you, or these are the products which customers like you have bought. So all that is done through machine learning, right? That's called a recommendation engine, and that's done through machine learning, right? And there's a course specifically on Mahout, which is the framework for doing writing recommendation engines, which is available on Edureka. If you're interested, you can take up that. Now there is a question: does a developer role also require domain knowledge? Well, I would say not require, but any anyone who's looking to write good code, right? According to me, I'm an old man now, but I always recommend people to understand the domain, right? So if you're in the retail domain, if you're writing a program for that, you need to understand what the domain has. So that's not a hardcore requirement, but that's something which will be useful and recommended for an analyst role or a data scientist. That becomes the key requirement, right? Because if you don't understand what you're trying to gain from the data, then probably usage of tools is, you'll just become a super user of a tool, right? Now there is a question from Jyoti which says, how much time it will take to become expert in Hadoop as a developer? Jyoti, depends upon your background. Can you quickly tell me, if you have a development background, what all languages do you know? Otherwise, I mean, it typically, I'll say, typically a 2 month time, if you're working, will be a good enough time to get a good hands-on on Hadoop, right? Where you will be expected to spend, say, at least 10 odd hours a week, right? So that is typically what I recommend for someone. And the way the course works is that you have classes every weekend, or if you're looking at a weekday batch, if you're urgent requirement, you can opt for that as well. Then there are classes every day, Monday to Friday, and in this case, there will be classes every weekend, 3-hour sessions, where and after every session, it will be recommended that you take up the assignments, quizzes, and the code, whatever code assignments are there, you take them up, and then finally do at least a couple of projects. So, and this typically takes 1.5 to 2 months, 6 to 8 weeks time to actually get that confidence that you can handle a project now. So Jyoti, since you are from a Java background, I think if you're a Java developer, then I think learning Hadoop will not be very difficult for you, because at the core of it, MapReduce is done in Java. So okay, so that's how it will be. Okay, I hope that answers your question. Okay, so your question, Chetan, right? What is big data? Now, there are a lot of concepts, there are a lot of misconceptions also there. Now, big data is not just about huge amount of data or large data. It's much more than that. So what you need to understand is that if your data runs into, say, terabytes and petabytes, if it is a few gigabytes, there's no point in using big data tool to actually analyze it, right? I mean, you can do as well in your normal analysis tools, right? If your data is huge, which amounts to terabytes or petabytes, and the data is complex, when I say complex, it means it's not just in a, say, a table format where you have structured data. If your data is text, your data is images, you have huge complex unstructured data, then it is difficult to manage that with normal tools. I mean, Oracle fails. I mean, even if the Exadata will fail after a certain size of the data, then it is termed as big data. Again, the not just the size of the data, not just the unstructured nature of the data, but also the fact that the the velocity at which the data is getting generated. So if your data is coming in at a very fast rate, say for example, data being collected by websites, right? That data comes in at a very fast rate. Every day you are getting, say, terabytes of data. Then analyzing that data, then that data is actually classified as big data. So three things: one, it should be huge in size; two, it should be complex in nature, which means it should be a lot, if it is a lot of unstructured data. And these days, I mean, because of the way we interact on the web, right, whether it is social media, whether it is e-commerce, there's a lot of unstructured data being collected, right? And I'll show you a graph which shows the rise of unstructured data. That's why the term big data and big data analytics has gained so much prominence. It's not just a bubble that, okay, big data is hot today. It's going to remain like this for quite some time, because as we develop more and more tools to analyze this data, gain insights from this data, there will be much more demand for trained people, as well as there'll be demand for creating new tools over it, right? So three things I talked about. If it is large, huge in size, which is typically terabytes and petabytes and not gigs, then the complexity of the data in terms of the whether it is unstructured image, clicks, likes, that kind of data. Third is the speed at which it is getting generated, the velocity of the data, right? So this is these are the 3 or 4 parameters which we use when we say whether this my data is big data or not, or whether I should use a big data tool to analyze this data or not. Okay, so, and the challenges, right? What are the challenges with big data? The first challenge is capturing the data itself. Like, you have multiple sources from where data is coming in your a typical data warehouse, right? There are multiple sources, but then it is still controlled. Here a huge amount of data is flowing in, and unstructured data is flowing in all the time, and capturing that data itself is the first challenge. Then curation of that data, removing anomalies from that data. Then the third part, which becomes very important, is where to store this data. Now I'll go into the details of how data is stored in Hadoop, but just to give you a view, right? If you have terabytes of data, to store that data into a single device and retrieve it back from a single device, even if you are using the fastest IO devices, will take hours and weeks at times. So what is the best way of storing that data? Okay, so that's the other challenge. Then obviously, since the data is huge and there's no pattern to that, searching that data becomes very difficult. Now if you have to sharing of this data, say for example, if there are 2 teams working on it, how do I share this data between 2 different teams? How do I make sure that the data which I analyze and I send it to a different team for doing a different analysis or a different tool, that also becomes very huge. Transferring of data, now the challenge becomes that though our storage devices have become huge, right? You can have terabytes of data in your pocket today, but still the speed at which you can transfer data from one storage device to another one is not at that level. I mean, you still take a lot of time, so that also is a challenge, right? Then analysis and visualization are the other 2 challenges. So analysis means that if I have to find patterns out of that data, that's analysis. That's where your machine learning, your statistical analysis comes into play. And visualization is to view the insights in a way that you can take decisions. So now you cannot take your terabytes of data and create a, say, Excel out of it and show it to your CEO. You need to show him that, okay, these are the trigger points where, say, some specific pattern is happening. So visualization becomes very, very important in this context, because you cannot look at that data otherwise. Unless and until you are able to visualize it in a proper way, it's not possible to take decisions based on that, because ultimately it's all about taking data driven decisions. All organizations today want to take data driven decisions. So that's where the visualization part becomes very important, right? So everyone knows what is a black box. I mean, in the past few months, you would have heard, right? So black box is the device in an aeroplane which captures each and every activity which is happening in the airplane. And typically, in unfortunate cases where, say, accident happens, they search for the black box, right? So the data which is inside a black box, will you classify that data as big data? Okay, so there is a mixed response there. Some people say yes, some people say no. Okay, so let me tell you some interesting trivia around it, right? So in a 30-minute flight itself, aeroplane generates a few terabytes of data. Okay, and all this data is unstructured data, because it captures audio signals, it captures pictures, it captures the conversation, it captures sensors data. So uh, that actually the black box actually contains the amount of data which black box contains is actually big data. Okay, and if you have to look at, say, a 10-hour flight, you will be capturing terabytes of data with all sorts of unstructured data that there. Okay, so does that clarify? Is everyone clear with that? Similarly, the data which say a retailer will be collecting, right, on his website, on the clicks, the page views, right, the data which is collected, say, in your web analytics, that also is very unstructured. So now the page views, the customer profile, the the pages the person clicked, the actions which a person did on your website, right? So all this data actually is used by e-commerce website, for example, to analyze that what is the right customer behavior, what is the how should I design my website, how should I present my data so that the customer is able to make decisions quick, right? So that's again classified as big data. But then if it's a small website which has, say, a million, maybe a million page views, then that's not really something where you need to put a NoSQL or a Hadoop. But if it is something like a Flipkart or a huge website with huge traffic, yes, you need to analyze that using a typical Hadoop, right? So now I have already told you about that. There's another view, right? Another example of big data, stock markets, right? Stock markets generate around 1 terabyte of new trade data per day, right? And lot of people, they use this data to analyze trends, on past trends. Based on that, they do predictions. So they do forecasting on based on that. They do the short term market call is taken based on this. So this is again a use case. Say a New York Stock Exchange will be internally using big data analytics to figure out what is going to happen tomorrow, right? Now, data is always as good as what you can, the insight you can gain out of it, right? So data is always sacrosanct, right? Data doesn't change. Whatever a customer is doing on a website remains the same. Now the question is, how reliable are the big data tools today, right? How reliable is the analysis which I can get out of that? I hope that's the question you had. So that's a good question. So till recent past, the tools were not capable of handling such data. Now with Hadoop coming in, for the past, I would say, for the past couple of years, now there's a lot of insight which you can gain from big data. There are real-time analytics available, wherein, say, for example, let me give you another example. I'll take up some of the examples, but since you've asked this question, say for example, you're using a credit card to make a transaction, right? Many a times you'll get a alert right at that time that this looks like a fraudulent transaction. The way it is done is that the payment gateways or the card companies build models around the behavior, right? Say for example, the IP address from which you are making the transaction, uh, the country from where you are making the size of the transaction, the ticket size of the transaction, your past transaction histories. Based on that, they figure out, they create a model, and if there is some anomaly in that, then they'll flag it as a high risk transaction. And at times, I'm sure you would have got a call very quickly from a bank saying that, oh, you just made a transaction, are you sure that this is the transaction you made, right? So has anyone noticed that these days you've started getting calls, and if you make some transaction from a credit card which they feel is a little suspicious? Has anyone seen that happening? Yes. Okay, so that's what is one of the use cases for real-time data analytics. Okay, and emails as well. Max says yes, emails as well. Okay, now the other question which comes in is Hadoop the best big data tool? Well, the jury is out, but Hadoop is the market leader. Now, there are many flavors of Hadoop, though. The reason why Hadoop is the market leader and it's used in most of the places is, one, because it is open source, right? So that gives anyone the flexibility. It is vendor agnostic, but there are many companies which give you Hadoop distribution. There is Cloudera, which probably arguably is the most popular. Then there's Hortonworks, then there is MapR. So there are various distributions, right? Very there are various distributions of Hadoop which are available, which essentially means that the backend Hadoop remains the same, but the way the tools on top of it, the tools for gaining insights out of it, the way the cluster setup is done, the administration tools, there are various companies which have built around that. Okay, what are the limitations of classifying normal data as big data? Well, if you see, you cannot, the way I answer this question is that you should not use a sword when you really need a knife, right? So that's the answer, right? If you the overhead of using, say, setting up a Hadoop cluster and using it, and there are a lot of things which you cannot actually do in Hadoop, which can be done in RDBMS, right? Those are the things which you have to look at while to use or not to use Hadoop. There is a blog which we've written on that. I'll send across that link to you after this class, right? You can read through that. Uh, there is another question which says related query to reliability. Does big data relax over the asset property? What is the yes, that's right. So now in the big data realm, there is, instead of SQL databases, you have no SQL databases, right? So there's something called a cap theorem, right? I'll not go into the details of that, just to give you a very very quick understanding of that. The cap theorem talks about consistency, partition tolerance, and availability. So these are the three things which are required for any NoSQL database, and any NoSQL database cannot be true to all these three properties. So depending upon the type of NoSQL database we are looking at, we either choose two of these properties, right? There's another blog which I've written on that. I can send you that in detail. But then the cap theorem is something which is used in this context, and NoSQL database do not guarantee the ACID properties. I hope that answers your question, Anup. So this is what I was talking about, right? The time when I grew up, right, and when I started working, there was hardly anything which was called unstructured data, and that was much before this period, right? I mean, I started working long back. Uh, but then in the age when you guys came in, I'm sure a lot of you guys came in the industry during this period when the unstructured data started booming. The reason for this coming up is that we started using a lot of web, right? We started using a lot of web applications. We became active on social media. We started maybe the match results and the live telecast which you're watching, right? That's also generating tons of data, right? So that's where the unstructured data, this is the growth of unstructured data, right? And across the web, and that's where it becomes all the more important to so basically that's why it becomes all the more important to analyze this data and take data driven decisions. Now with what is IDC, which is International Data Corporation, which is a very well known research organization, has predicted that it will reach 40 zettabytes, but I'm sure it will cross that as well, right? Now another trivia here is the world's information is doubling every 2 years. So by 2020 the world will generate 50 times the amount of data, and 75 times the number of containers which you have now. So that's the reason why big data analytics becomes so important, and that's why it is important for all of us. I mean, though I come from, say, those days of DBase and Fortran, that's where I learned my first I'm sure not many people would have heard those names, a DBase or a Fortran, right? That's where I started my career on programming. But now everyone has to change. Everyone needs to understand that the use of this, whether it is the CEO of the company or even the HR of the company, the HR analytics tools are available there. Everyone wants to take a data driven decision. So, and that's where learning this technology becomes all the more important, right? Okay, so this is some trivia. Let's jump now to something more in detail. I've talked about this, right? Already spoken about the volume, velocity, the variety of the data, and the veracity of the data, right? So, this is IBM's definition of big data, right? I've already spoken about it, so I'll just move on. If you have questions, you can just put them on the chat window. So let me introduce you to Annie. Annie, when I take sessions, Annie is my companion. She asks you questions. So she'll ask you questions today also, which you'll have to answer, just to make the session a little interactive and to keep you engaged. And Annie is very tough on me most of the time. She'll ask questions which she knows I'll not be able to answer. So I'm sure, and my job is to make sure that all of you are able to answer Annie's questions. Okay, so let's see what Annie has. Now, okay, so the first question Annie has, and she's testing my knowledge and not yours. She's asking, map the following to the corresponding data type. XML files, email body. Will you classify that as unstructured or structured data? Can you answer that quickly? Structured. You can write S for structured and U for unstructured. Great. So a lot of people here have given the right answer. So I'm not really. So that's actually XML and email body is a semi-structured data, right? because it has, though it's not in a complete table format, but it still has, say, a tag which specifies this is what it is. A email body is also like that. So there's semi-structured data. How about audio, video, images, and archive documents? Quickly. Okay, great. So Annie, I've won it here. Everyone has said this is the unstructured data. So congratulations, guys. Thank you very much. Anyone who thought it is structured data, audio, video, images, documents, these all form unstructured data. Okay, and that's where, when these become huge and when these start coming in at a very fast pace, that's where you need big data analytics. Okay, great. Data from enterprise systems, ERP or a CRM, how will you classify that? Structured, unstructured, or semi-structured? Great. So yes, so that's basically that's basically the structured data format. So now at least all of you have understood what is big data, what is unstructured data, what is semi-structured data, and what is unstructured data. Okay. And yes, big data analytics will be used on unstructured and semi-structured data. Okay. Okay. So let's move on then. Thank you, Annie, for coming in, and let's see if we're able to answer other questions from her. So Annie has given us the right answer now. Okay. So there are a few more. I mean, you'll get these files as well. You'll get the recordings as well. But there are a few further readings. These are some of the blogs which you may want to look at, right? Which talk about what are the Hadoop, Hadoop, what is big data, some characteristics of Hadoop. I'll suggest that after this session, please go through these, right? You'll get these all these links in your email, right? Okay. Okay, so let's come to some typical customer scenarios or big data use cases, right? I've talked about it, but let me put it. I spoke about it in a very unstructured fashion. Let me give you a structured way of looking at it. So one domain which is very hot and which very much requires your big data is the consumer internet, right? Consumer internet. When I talk about consumer internet, is a B2C kind of a uh, website, whether it is a eBay or a Amazon or a Flipkart or a Jabong or a Snapdeal, whatever, right? So that's where it- big data analytics plays a very big role. Now, what are the things which they do there, right? So I'll not talk about everything, but some of the typical things which, say, I would be doing if I were using big data there. One is recommendation engines, right? Now, how many of you have actually seen and be true there, that when you went to buy, say, a shoe, right, and it was showing some other products which will go along with that shoe? How many of people have seen that? Can you give me a yes or a no? Everyone has done. Okay, so everyone has seen it. So that's, how it is done. So based on your behavior and the behavior of users like you, right, uh, they build a recommendation engine inside it. And this recommendation engine is typically been built inside a tool called Mahout, which is again a part of the Hadoop ecosystem. And recommendation engines give suggestions, right? Maybe suggestions like, you may also like, right? So that's the kind of recommendation engines which are being used behind the scenes to give you the right products, to show you the right products. Ad targeting. Now, how many times have you seen that you visited a website, and when you went to the Facebook page, your Facebook page, you started seeing their ads? How many people have seen that? So everyone has seen that. So this targeting, the specific case I'm talking about, is called retargeting or remarketing, where depending on, when you go to a website, I mean, you visit Edureka today, I'm sure you'll start seeing ads across the web of Edureka. The way it is done is that Google or a Facebook puts a query in your browser, and then depending upon your behavior on the site, it will show you appropriate products which you had looked out for. Okay, so that's called retargeting. That also requires big data analytics. Now, recommendation engines are built offline. Anup had a question: are these recommendation engines static? uh, are they built offline? Yes, they'll be built offline, but then they will they'll not be really static in the sense, because they will keep on improving depending upon the data they're going through. So now, there's something called supervised learning. I'll not go into the details of that, but that the way typically it works is that you have a training set, okay, and you have one data, and you derive a result out of it. Now this your model, the model which you've built for the recommendation engine, keeps improving itself by looking at as more data starts flowing in. So your recommendation engine is as good as the number of people who have passed through it, or the number of visitors have passed through it. Which is tool used for recommendation engines? It's called Apache Mahout. It's spelled, I'll show you that. It is spelled as Mahout. Mahout. Okay. Now search quality. Now, well, you go to a website, right? Go to Amazon, right? And you type I want to learn big data, right? It will give you so many books, it will give you some CDs, it will give you some random, it should not show you a dress right there, right? If you see a dress, you'll not be clicking that, right? So so that's where improving the search quality. And how does it improve? You also see that, okay, users typed this, though you had a product which actually was for that particular search, but that product did not show up. So you analyze that and keep on improving your search results by tagging different products with different IDs, right? Does that make sense, guys? Search quality, how does the search quality improve by looking at the customer data? How does it fit into a consumer internet space? Abuse and click fraud detection. Now this is what I was talking about. Right now, if you're using a credit card which is a stolen credit card, I'm sure no one of you will be using that, but if your credit card also gets stolen, it is getting used, right? What will happen there is that now a lot of these payment gateways now have sophisticated engines which can detect fraud. So what they do is they how will they start? They'll put a few filter criterias that, okay, if anything which this doesn't fall into this criteria, flag it as high risk, right? Now as more and more transactions start happening, this system is auto becomes more and more strong automatically. That's based on the data which it goes through. Now sometimes they will give you a call, just though you have made the transaction, it still falls in your credit limit, but they'll still give you a call. Now when they'll get this data, okay, this was a fine transaction, this was not a fraud transaction, their engine keeps improving. So that's how the abuse and click fraud detection is done in using big data analytics, right? So everyone has understood the application, at least at the very high level. When we do go into the course, we will be picking up each of these data sets from each of these domains, and we'll doing it actually practically. But at this point of time, the expectation is not that. The expectation from you is that, have you understood at a very high level, how does big data analytics play into the consumer internet space? Can I get a yes or a no? Great, thank you very much. Okay, so let's get to the other domain, telecom. Telecom is big, uses big data like anything, right? Now, what are the typical very high level use cases there? Internet usage, right? Calling records, right? Very good. Subscriber usage and plans thereby, right? Yes. So basically, what telecom companies want is that they have limited network, right? So they want to optimize their network performance based on the usage. So if I know, okay, during night times, the people who are not in my age, because I sleep early, I don't know, but teenagers, some of you probably, right, will be always on phone, right? So they know, okay, these are the kind of subscribers which need more bandwidth in the night, and these are the people who need more bandwidth in the daytime. So they optimize their bandwidth utilization routing based on this. So then the customer churn prevention. Now can anyone tell me what is customer churn? What is customer churn prevention? Anyone can answer that? Can anyone tell me what is customer churn? Okay, very good. So Chaitanya has given me an answer: moving to other vendors, dropping the service, drop in customer usage. Exactly. How will I figure out that, how to make sure that my customer churn is low, right? By giving them right offers at the time. If I notice that, okay, there is a usage drop which has happened, maybe such a give them if they're using, say, roaming, they give them some plan which will, say, a 10 rupee top up plan using which they'll stay back. So all these things are done through huge amount of data coming in. That data has to be analyzed, and almost real time actions have to be taken. So that's how customer churn prevention becomes a very important use case, because it directly affects the revenue or the top line of the companies, right? Then the call data record analysis. Now almost all the calls across all providers are recorded. Okay, though they'll not put this is the person, they'll not listen to your records, but anywhere if you need to uh, look at the call records, that is required, and that's a lot of huge amount of audio data. That analysis, the timing of the record, calling, again you have to figure out, okay, what is the typical timings when these people call, so that you can not only do espionage on that, but also to route your network or optimize your network usage based on that, right? Again, if you know that, okay, say during say holidays or festivals, or during say for example World Cup, lot of usage is happening on the internet, right? So they know, okay, it should not happen that the day India wins the World Cup, you're not able to look into any of these cricket scoring sites, right? So not only from the side of your or your website, it has to be taken care, but also from the network side. How many times you've seen that on a new year you are not able to make calls, the calls get dropped, right? So that's what they want to look at. So is the application of big data analytics in telecommunications clear to everyone, but at a very high level? Can I quickly get a yes, please? Great. So let's move on to another use case, a couple of more use cases. Government, right? Fraud detection and cyber security, welfare schemes. Aadhaar, everyone is aware of in India, so that uses and a similar kind of usage there, right? So that's again a use case. Then healthcare and life sciences is one huge area where do these days, because of the availability of these so yeah, healthcare is very is a very important domain in which there's huge amount of data. There's gene sequencing which is done these days. We are able to figure out the right vaccines for a particular epidemic, or a particular disease which may just spread. So those are the things, and also understanding that how will a particular, say, a swine flu will spread over a geography, right? All this thing is done through big data analytics. Okay, a couple of more use cases and then I'll go into some detail there. Banks and retail, I mean, point of sale transaction analysis, again is a very retail. I mean, your Sears, your Targets, your big bazaars, all of these have a lot of transactional data which they want to analyze and do a sentiment analysis on, right? So that's again a very important use case there. Now I've already spoken about financial services, so I'll not go into details there. Then you can use this link to see what are the other companies which are using big data, right? So this is Apache link. Now let's take one use case and go a little detailed into it, right? So let's talk about Sears. So Sears is everyone knows what Sears is. Sears is a huge retail chain, and they wanted to get some, they were doing a lot of analysis, but they were not getting a lot of insights using their current systems. So what they were using earlier was they were using a combination of Oracle Exadata, Teradata, and top of it they were using SAS for to store, process, and to gain their customer activity analysis. But then what was happening was that they were not able to get some key early indicators, right, which were important. I'll go into a diagram. So they moved to Hadoop, and what did they do? Let's look at that. So this is how it was. This is how their warehouse and their business intelligence thing will look like, right? So initially, what they had was that, sorry, there's a mistake here. Instrumentation means your point of sale systems. Then you basically do a collection in your warehouse, and all this raw data was used in a storage grid, right? So what they did, what the challenge which they were facing was that when they moved this data, right, into the when they did into their warehouse, they were not able to take all the data together, right, because of the size, right? I mean, only there was some 2 petabytes of data available, right, for doing some business, running some business intelligence reports. But out of that, only 10% of data was getting in. Other 90% of the data was dying prematurely. Okay, so then what this essentially means is that since you are scaling down the size of your data, you cannot actually do very the scope of your analysis, or the accuracy of analysis gives you only so much, right? So so that was the system which they were using earlier, right? So a lot of their high fidelity raw data they could not process, they could not gain insights out of it. So what did they do, right? This whole thing, right, the storage grid, the ETL compute grid, and your only taking out a part of this data, they wanted to analyze their complete data together. So that's where they came up with a uh, different architecture, which was this. So the instrumentation and collection was stores data into their storage and compute grid, which is Hadoop. Okay, two things: there's no data archiving, the data is live forever. I will go into the details of how Hadoop stores this data and how Hadoop is able to keep all this huge amount of data together. I'll get into that, but let's assume that Hadoop is able to store this data together. Now if you are able to have the whole data together is available for processing, and Hadoop actually also helps in processing huge amount of data at a very fast rate. So using this, replacing their earlier warehousing components, when they moved to Hadoop, they were able to gain much more insights, right? Right now Hadoop CS runs on a 3300 node Hadoop cluster, and 100% of its data is available for processing, rather than the early 10% of the data which was existing for non-Hadoop solutions. Now since you have so much data available, you can look at all your high fidelity data, and you can take a much more informed decision, and much earlier in your, before you get to know about the trend, right? So that's a use case, that is how architectural change had at Sears happened, right? So now okay, so there's a question from Anu. When you say premature death of raw data, do you mean that they couldn't store most of the data, that data in a table structure of RDBMS? Yes and no, both. So what happens is that, I mean, even if you store all that data, when you move it into your warehouse, you actually don't take all the data for your BI, right? You only pick, based on some filtering criteria, you pick only a part of it. Now, obviously, when you filter something, your sample size goes down, and the kind of analysis you'll get, the kind of insights you'll get will be much lesser than what you can get if you could get the whole data. Okay, so fine, great. So now with this solution, where they use Hadoop, on top of it they can use their BI tools, they can use their visualization tools, they can run statistical analysis, they're able to get much more than that. So this is the typical change which is happening across organizations. That's why I wanted to bring this thing. First wanted to introduce you to the various organizations or the domains which use big data, and now then to tell you how are they changing their data storage and processing. Does this make sense, guys? Does this add any value to what we've studied? So the question I have is, do you understand where is big data used, and what are domains, and how a typical big data architecture, because of big data, your storage and compute architecture changes? Great. So let's move on. Now we'll get a little bit into the Hadoop, right? What is Hadoop, and how does Hadoop actually help in all this? We've seen that Hadoop does something. It's some magical solution. So let me ask this question to you before we get to Hadoop. So say we have one machine, right, and we have 4 IO channels, right? Each channel has a speed of retrieving the IO speed is 100 MB per second, right? So can you tell me that if I have to retrieve 1 TB of data, if I have to read 1 TB of data in the left hand side, how much time will it take? And you have 4 channels through which you can read it in parallel, and each channel has 100 MB per second data retrieval speed. So how much time will it take to read this the complete data, 1 TB of data? It will take 43 minutes to retrieve this data, just 1 TB of data. And on top of that data, you have to do your analysis. So this is the challenge, because of which you have to get to Hadoop. Now, this is when you store it in one machine with a very good storage. Now, there's no limit to how much data you can store. You can store petabytes of data in here. But the challenge is not about storage. The challenge is about moving that data fast, for retrieving that data very fast. Similarly, right, so what we can do, the solution, so you understand the challenge there. The challenge is not around your data storage has scaled up, but the speed at which you can retrieve data for analysis has gone down. Now imagine Facebook, which has 500 TB of data coming in every day, and they have to churn that data multiple times a day, right? How much will they be able to do any analysis on top of it if they were be using such a system, right? The answer is no, right? So Anup, yes, you're right. So it'll take around 45 minutes now, but it's not about the actual time. The sense which I want to give you is that the challenge is not about storing the data, but about moving the data around. So that the challenge comes in how fast I can process the data. The limit comes, or the limitation comes, the bottleneck comes on the IO speeds, which have not scaled as our storage spaces have scaled. Okay, so the solution could be, instead of that, if I could, on the right hand side you can see a picture where I'm storing this data, distribute this data on say on 10 machines. Now how much time will it take? Will you have to calculate that, or you can give me the answer quickly? Great. So yes, so it will take around 4.3 seconds or whatever, right? So now this is essentially what Hadoop does, right? So Hadoop, what it does is, instead of storing data at a single location, it stores it in a distributed fashion, and it follows a distributed file system, right? Where instead of storing a data in a single place, you can have hundreds of nodes of the cluster data nodes where you can store your data, and you can retrieve that data in parallel. So that's where the power of Hadoop comes in. And you can have clusters of say as low as say 4 node cluster, which means that there are 4 nodes where the data is stored, and they can go as big as say a 10,000 node cluster, which would be used by a Yahoo or a Facebook, right? So is this clear, the challenge here? Exactly. So Anjaneya has given a very good analogy here. If we have 100 node bundles, around 10, one person will take time, and if you shall distribute to 10 people, it will take less time. So that's exactly what is done. Divide and conquer is the policy here. So now, so that's the principle on which Hadoop also works. So you have a cluster where you store your data, distributed data, and then you have a so now coming to the definition, though I'm not a big fan of definitions, but let me just quickly tell you. So that is the essence. That is how Hadoop is able to do all this analysis, and at a fast speed is able to store this data at such a huge amount of data, right? So Apache Hadoop is a framework. Now, the important thing to note here is that Hadoop is not just one tool, it is a framework that allows distributed processing of large data sets across clusters of commodity computers using a simple programming model. Now, the reason why I picked up this definition is that a few key things, right? Distributed processing of large data sets. So your data is not stored at one place. Your data is not input and output doesn't happen from one place. It is stored across a cluster. Then these systems, right, where you store this data, they may not be your very sophisticated systems. You can use commodity computers there. So that also brings down the overall cost, right? Using a simple programming model, which the programming model is called MapReduce, right? I'll not go into that now, but the way it works is that you store your data across a cluster of computers, and then there is a framework, a programming model, which takes care of synchronizing data. If you're reading the data, from where to read the data, where the so all these things are taken care by the system. If you're running a job which has to take data from multiple clusters, how do you retrieve this data, or how do you where should the program be run? All this is taken care by the Hadoop framework itself. Okay, and there is a simple programming model which is called MapReduce programming, and which runs on top of it. Okay, so is this clear? And it's a open source data management. So is this part clear, guys? Okay, great. So Rohan has posted this question again. Does Google's recent self-drive car project also potentially use big data to analyze images and pass decisions across cars and traffic situations to learn moves? Right, definitely yes. So there are two things which it does. One is uh, looking at the historical data and building models around that, and then doing real-time decisions, because there you really need real-time decisions. That okay, there is something which is coming. What should I call this thing? Should I put a brake? Should I accelerate? Should I take a left or a right? All this thing has to be done on the real time. So yes, the Google Maps, the self-drive car is essentially using big data analytics. Okay. So this part is clear to everyone. A little bit understanding of how is Hadoop different from your normal database. And then it can, the other important thing is that it doesn't store data in tables. It is stored as a flat file structure. Okay, so it's like a flat file structure, and it's a distributed file system which is used, built on top of a Linux kind of environment. Okay. There's a question from Lohit. Is MapReduce the only technique used by Hadoop? Good question. A little early in the session though. The answer is no. In Hadoop 1, MapReduce was the only load which you could take on the Hadoop. But with Hadoop 2.0, you can take different type of jobs as well. I will cover that towards the end of the session, Lohit. Please mark this question. Okay. I'll go into the details. What are the other type of jobs which can be run? Okay. So now a question from Annie. Very important concept here, which you have to be very careful about this question. Hadoop is a framework that allows for distributed processing of small data sets or large data sets. Can everyone answer, please? Okay. So large data sets. The reason this is very obvious, but still the reason why I brought this question in here was that if you have say small data sets, right, if your file sizes, the data which you're trying to analyze is very small, and please pay attention to this, right? If your file sizes or the chunk of the data is very small, the overhead becomes much more than the advantage which you get out of Hadoop. So in case you have data which is very small data, which has huge amount of data but divided into small chunks, it's a good idea to concatenate this data and make it say a few GBs for each file, right? So is that clear to everyone? That huge amount of data, but if it is in small data sets, then it becomes overhead. Hadoop will not be the best way to analyze it. Before that, you'll have to do some pre-processing, concatenate some data and make it large. Okay, is that clear? Can't small data sets be used on a single node cluster rather given to a single node? Well, see, it's not about a single node or a multi-node, Anup. The fact is that when you run your MapReduce job, right? I'm getting a little technical here, but then you'll have to do a lot of bookmarking. You have to do a lot of overheads flags around it, right? So if you have the metadata itself associated with that actual data becomes too much. So if you have a 1 KB file and if you have a 2 KB of tag data alongside, that defeats the whole purpose, right? That's why small data sets are not preferred. Does that answer the question? I'm sure a lot of people will have that question. Good question. Thank you very much. Is that clear? Okay, great. Right. So that's what Annie answers, and very much in line with what we discussed. Now let's come to the Hadoop ecosystem, right? So Hadoop is not one tool, but that should be very clear in your mind. If someone asks you what is Hadoop, Hadoop is not one tool. It's an ecosystem. It's a framework, right? So what are the various things in Hadoop? Let's start right from the bottom, right? Where sorry, the the place where you actually get the data into the Hadoop, right? So Hadoop has something called HDFS, which is the Hadoop distributed file system, which is nothing but the file system which is on top of the cluster, right? So that's called the Hadoop distributed file system. Now all the data is stored in the Hadoop distributed file system or the HDFS. Okay. Now how do you move data into Hadoop? How do you move data into Hadoop? There are multiple ways of doing that. So there's a tool called Flume, which is mostly used for moving unstructured or semi-structured data into Hadoop. You can also store structured data in Hadoop. Okay, it doesn't stop you from storing structured data. So if you have say data coming from web, if you have data coming from, there's a few icons here, LinkedIn, Twitter, any of the RSS feeds, right? Anything which is coming from web, the loading method for that data into HDFS is done through Flume. So what Flume does is it is a tool which forms the channel with the HDFS from your external data source, and it can flow in data inside Hadoop, right? And mostly used for, this is the first part, data ingestion into Hadoop. Then if you have data say in your traditional RDBMS from MySQL, there's a connector for MySQL to Hadoop, there's a connector for your Oracle database, there's a connector for MS SQL Server to Hadoop, and there's a tool called Scoop which does that. I'll not go into the details of any of these tools here. When we get into the course, all these are covered in detail and you're shown, and you yourself move data. That's the first step, right? So, but it is the full form of this is SQL to Hadoop. So that's where the word Scoop comes from, right? So if you have to move structured data into Hadoop, or when we talk about say Hadoop, we are essentially talking about HDFS, right? So that's where your the tool Scoop comes in, and you move data into Hadoop using Scoop. And you can move data from any of the RDBMS tools. All the tools have connectors available for Hadoop now. Okay. Then on top of it, right now, this is your, assume this is your cluster, right? On top of this cluster, you need to have a system or a framework which can do resource management. Say when you run a job on Hadoop, right? If you run a program on Hadoop, there has to be a framework which can see where should this job be run, where should I find this data, where should I store this data, where should I take this data and move to, right? So all that is done by a framework called Yarn, right? Yarn stands for yet another resource negotiator. Don't worry about too much of abbreviations here or acronyms here. But this Yarn, what Yarn does is it manages, it is the framework which manages the complete resource management. I'll go into the details of Yarn later on in this class itself, right? Then you have something called a MapReduce framework, right? The MapReduce framework is the framework which is used, is one of the framework which is used on top of Hadoop, right? To process the jobs, right? So you write your programs in MapReduce, and then that program is broken and sent to the different nodes on the cluster, where the actual data resides, and you collect your results and you come back. In this session, I'll not go into details of how does the MapReduce work, right? Probably some other day we'll discuss about that. Then there is a tool which is called Hive. Hive is a tool which essentially internally uses MapReduce, but it gives you the flexibility. So people who are not, say, from a programming background, right, and the people who have come from a SQL background. So Hive is a language called Hive Query Language, or HQL, which is very similar to SQL, where you can write queries very similar to SQL to retrieve and do analysis on the data. Okay, so that's the tool Hive here. Okay, then, and this was developed by Facebook, by the way. Then you have something called a Pig. Pig is tool which was developed by Yahoo, and it is again used for data analysis. You can write scripts. You don't need to write your extensive MapReduce programs. You can write scripts in Pig for data analysis, and this is also a part of the course. We get into that. And then Mahout is the machine learning tool I talked about, right? Then there are other frameworks also. You can run a graph job, you can do a real-time analytics job, which is again on in parallel to MapReduce framework. You can use these frameworks as well. Okay, so in Hadoop 1.0, the earlier release of Hadoop, only MapReduce was supported. There was a question that only MapReduce can be run. Now with Yarn coming in, you can actually do a lot of other things on top of it. Then there is a NoSQL database, which is a part of the Hadoop ecosystem, which is called HBase, right? On in which you can store your data in a column only fashion. And I'll not go into the details, but this is the NoSQL database, and on top of Hadoop. Then there is a tool which is called Apache Uzi, which is for the workflow management. For example, if you're running thousands of jobs, you want to analyze, you want to manage the workflow there. So that's where this tool is used. So any questions on the Hadoop framework? Otherwise, I'll move on. There's a question from Anup. Does Scoop store the file as is? An Excel format is proprietary. Why should anyone store that in HDFS? Are there use cases of analyzing structured data using Hadoop? Yes. Okay. So basically, from wherever you get the data, right, you can actually create tables inside Hadoop as well, and it will be stored in a table format there. So yes, Hadoop Scoop will take the file and store it in that format. Now there are use cases. Say for example, I'll give you a use case where there's a question which you've asked. So I'll give you a use case. Say for example, you are analyzing insurance data, right? So the kind of policies people have taken, right, and the area which they reside in, the kind of diseases which this area may be afflicted with. So this essentially will be a structured data, and then there'll be some unstructured data on top of it, that the region or the map where this is located. And you, in an insurance company, wants to propose a pricing for a health policy in that area, right? Or to know that what will be the typical health related problems these areas of people of this area will face. So this will be this is a use case which is used for analyzing this kind of thing, right? Is that clear, Anu? Anjane is asking, any kind of structure unstructured data can be transferred to Hadoop? Yes. So this is an answer, right? It can be a combination of structured and unstructured data as well. Okay. Does that answer your question, guys? Quickly, yes, I'll move ahead. Okay, so yeah, so another picture, another way of looking at it. So, so there is underlying. So I've divided this into two parts here, which is that this line divides. So there is the Hadoop cluster, which has the cluster. The cluster has two major components here, right? There's something called a name node, and there's something called a data node. Now, a data node is the place where your actual data is stored. Your actual unstructured or structured data is stored. The name node is the node which contains the metadata around this data node, which essentially means the directory structure. Where do I find this data? Uh, any other meta information regarding this cluster is stored in the name node. Okay, so name node has to be a very high reliability machine, whereas the data nodes can be machines which may not be very high reliability. They can go down, they can come up. The complete framework takes care of that. So there are two types of nodes here. One is the name node and the other one is the data node. On top, from the framework point of view, there are two things here. The yarn is the complete framework. That is something called a resource manager, which is I would say not necessary in the name node, but then for the sake of simplicity, let's assume that that resides in the name node, which takes care of the overall resource management, right? And then there is something called a node manager, which sits on the data node, which manages the data inside, or the jobs which are running inside the data node. Okay, so is that clear, guys? uh, okay, so there's a question on what is the role of HBase. Okay, I'll just tell you. So see, basically, Hadoop stores everything in unstructured in that text format, right? Now, you want sometimes you want data in real time as well from it. So HBase is a NoSQL database which essentially stores the data. The data store still remains Hadoop, but on top of it, it appears like your RDBMS, right? With obviously some constraints. I'll not go into that, but then uh, you can actually retrieve data. You can create tables inside it. You can retrieve data. Online retrieval of data is possible using HBase or any other NoSQL database. But the actual data is still stored inside Hadoop itself. I can forward a blog on how does HBase work after this class, right? So at some level you've understood how it works. HBase is a NoSQL database, which is a column oriented database. I can tell you, and you can add you can add as many columns as possible in that, and on real time also you can keep adding columns. Say for example, your LinkedIn profile, right? That is a structured data where you fill in, but there are uh, but you can add more columns to it, right? As you progress. So a typical LinkedIn kind of profile, right, where the number of columns is not fixed, is something which is a good case where you will use HBase, right? Similarly, when you HBase is also used in these chatting applications. I don't know what proprietary technology Citrix uses for this, the but the Facebook Messenger actually is built on HBase. Uh, Usually, Ramadevi, transactions are something which people don't want to do in a NoSQL or a Hadoop kind of thing, right? For transactions, no, right? But for applications where you need real-time thing, like say for example a chat thing where you send me a message, I should get a message. HBase is used say in Facebook chat. I'm not aware of what goes inside your chat window here, but typically something like a HBase will be used as per my understanding. Okay, so is that clear? Good. So you understood the role. What is a name node? What is a data node? Data node stores the actual data. Name node stores the metadata and controls the overall cluster, right? Then Yarn is the framework, which actually is the software on top of it. There's something called a resource manager, and then there's something called a node manager, right? So node manager manages the jobs at the data node level. Resource manager manages the overall jobs, right? Okay, is that clear, guys? Any questions around this? Else I'll move ahead. Thank you very much, guys. Okay, so now coming to a typical use case, right? The question which people ask is that what is a typical configuration of a data node? What is a typical configuration of a name node? There's a new term which I've introduced here, right? Which is called secondary name node. I'll talk about that as well right now. But before that, a typical name node, right? A name node is should be a high reliable machine, right? If you look at this uh, configuration itself, you'll be able to figure out, right? I'm talking about a Xenon with 8 cores, 1 TB of hard disk, right? 64 GB RAM, Ethernet of fast Ethernet there, and 64-bit OS. And one very important thing is redundant power supply, which becomes very important because this is the nerve center of your cluster. If this goes down, that you are in a mess, right? In the Hadoop 2.0, we have a concept called a standby name node as well, which is a in Hadoop 1 we just had active name node, which was a single point of failure there. In the new version of Hadoop, which is being adopted now, there's something called a standby name node as well, which works alongside the name node, and if for some reason this goes down, this takes over. Okay, so now this is the name node and the standby name node. Everyone has understood active name node and standby name node? If yes, then I'll move on to the secondary name node. This is very important concept to be understood, the secondary name node concept. So I just want a quick yes. Don't be frugal on giving me a yes, guys. If possible, everyone can type a Y, right? That gives me some view that okay. Yeah. So Anjani, I'm coming to the difference between secondary and standby name node. Good question. What is CentOS? CentOS is it's like your Red Hat. It's a Linux flavor. Okay. 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 Good. So there are questions which are coming on the secondary name node. What is the secondary name node? So the active name node is the one which controls the cluster, right? The standby name node is someone who actually remains in standby. As soon as the active name node goes down, this standby name node takes the control. A secondary name node, this name actually is a misnomer. Many a times people feel that okay, secondary name node will be a standby name node, but it is not. What it does is it just keeps whatever is the data in the RAM of your active name node, it keeps persisting onto the disk, which means it keeps copying onto the disk. It doesn't take over. It is not as capable as name node. It cannot, if the name nodes go down, the secondary name node cannot run the system. It is just for as a backup mechanism in terms of a failure, that if you have to say, if your name node goes down and you are taking backup every 30 minutes, then the secondary name node will be storing the image of your RAM at any point of time, right? So is that clear? Secondary name node does not take over. It is not a failover mechanism. The failover mechanism is your standby name node. Secondary name node is just keeping a copy of whatever is the data inside the RAM of the active name node. Okay, is that clear, guys? And that's why it requires a lesser configuration, right? And that's why it is not as powerful as your name node. Got it? Yes. So a little surprising, Manikam is asking a little surprising thing, that Hadoop 1.0 did not have high availability, a cluster that has a single point of failure. Yes, that's right. So Hadoop 1.0 worked like that, but then good question there, because see, the name node itself has to be a rockstar machine, right? I give an example at times, right? If your name node is your Lamborghini, then your data nodes can be your ambassador cars, right? So it has to be such a machine where you'll hardly see any failures, right? But then, so there were hardly any failures on the name node side, but there were a lot of failures on the data node side. Now in Hadoop 2.0, the standby name node concept has been introduced, right? Secondary, so everyone understands the concept of secondary name node. Secondary name node never takes over the active name node. Okay, it's only the standby name node which will take over. Your secondary name node is like an assistant to the active name node. What it does is that whatever is in the name node, it will keep copying that onto a disk, right? So that in case of failure, you can take the image which was last stored and retrieve, get started from there. So that's the only purpose of that, right? So it does not take over. That's a very important concept to understand. It is the standby name node which will take over. The secondary name node will never act as a failover mechanism. Okay, so then why is it required? The reason why it is required is that in case the name node fails, you still have a copy of whatever was happening inside the name node. Okay, So that's the reason why it is required. It is optional though, okay, it's not mandatory. You can actually copy data directly from the secondary name node. When you say, let me give you a practical example, right? If the name node goes down, what will be the first step you will do? You will switch on the name node once again. You will move all the data which is there in the secondary name node into the active name node and restart. Okay, so that's the purpose of that. Okay. Okay, so if this is clear, then your data nodes can be your, I mean, a data node can be your laptop as well, right? It is a commodity hardware which can be used for data node, and data nodes keep failing. The name node keeps switching that. Okay, if this is failing, I should take it from there. And one more important thing to understand here is that Hadoop stores replicates the data. So whatever is getting stored in a data node, by default, 3 copies of that are stored in different data nodes. Okay, so that's something which is very important to understand. That's why in case of a data node failure, the data is not lost. Okay, so by default, 3 is the number of copies of the data which are stored across data nodes. So if a data node goes down, the name node knows, okay, if this data is available at this place, so it will redirect the program to that place. Okay, let's go ahead. So this is how the typical architecture will look like. There'll be a master machine which is accessible on this port. There's a resource manager which will be accessible on this port, right? Name node is a name node is a daemon, and resource manager will be again a software running there. And then there are your slaves. Your slave will have a data node running. Now data node, though it's not a hardware per se, it's a daemon which is running on that hardware, right? And similarly, a node manager will be a piece of software which will be running on the slave machine. Okay, so this is how it looks like, and these are the ports on which this will be available. Let's move on. Now again, it is the same thing but in a different view, so that you are able to understand the overall, visualize what we are talking about. Now in this case, what is happening is, this is the client, right, from where you load your data. This data on the, there are 2 parts to it, which is the one is the HDFS side, which is the storage side. The other part is your yarn, which is your framework side. Now anyways, the underlying thing is name node, data node, and the in this case, the name node interacts with the data node. On the yarn side, the resource manager interacts with the node manager, whereas the data node is where the program is run. So is this diagram clear to everyone, that how does this is the processing side, this is the storage side? Okay, the name node contains all the metadata, this contains the actual data. The node manager is running on top of the data node, and the resource manager interacts with the node manager to make sure what job is allocated to each node manager. Node manager inside it runs the jobs on the data node and gives the signal back to the resource manager. Okay, are these nodes geographically separated? If yes, how will the performance be affected? Very good question, Manoj. Typically we don't want to do that, okay, but it is possible, right? There can be nodes which are separated out geographically. The framework doesn't stop you to do that, but it's a very good idea to have it in a same data center. Okay, because if it is across geographies, then the data movement wherever it happens, right, will consume more time, so the performance will be slightly lower. Okay, are the data nodes on both sides? Okay, so Gopinath, the data node is, you can assume that is the slave, right? Or so data node is the thing with which the name node interacts with. Now at this level we are talking about the name we are talking about the master. So on the master, name node and resource managers are there. On the slaves, node manager and data node are there. Now data node is not really a hardware, it is a daemon, right? It's a program which is running on the slave. Okay, does that clarify? But for all the storage purpose, or for all the HDFS related activities, name node, which is again a program running on your master, interacts with the data nodes. For all the resource allocation and processing related work, resource manager interacts with the node manager. Okay, which is again running on the slow. Okay, so in this case, HBase does not come through this part, right? HBase will be, if there is HBase, the question is, where would HBase in all this, right? Okay, so HBase actually directly interacts with the HDFS. So it has a separate view of the files. It can directly interact with the HDFS. I'll not go into too much details. Is Yarn's main job is doing analytics on the node manager's data stream to it? Yes. So Yarn is the framework which contains the resource manager and the node managers. Yarn will have multiple things. One, it will allocate the resources. It will keep a check on what jobs are running, what are not running, what are failed, what are completed. Okay, that is what it does. And then when your programs are completing, giving the data back to the client is something which the Yarn does. Okay. Great. Okay. So let's move on if this is clear. Now this is a little complex. Okay. So I'll say it is possible that you may not be able to understand everything here, but I still wanted to introduce this here because it's an important concept here. So basically, this is how the Hadoop 1.0 structure look like. So I'm talking about federation. There was a question which I believe Jyoti or someone asked, how many data nodes can be there, right, in a Hadoop cluster. So this is the answer to that, right? This is how in Hadoop 1.0 there was just one name node available, right? And I'm not talking about a active and a passive name node. I'm talking about there was one name node and there was the secondary name node, whatever. But here, but what happened was that as we added more data, right, what does the name node store? It stores the metadata, and everything is stored in its active memory, which is the RAM. As we go beyond, say, 4,000, 5,000 nodes in the machine, the name node's active memory starts becoming a bottleneck. Okay, so all your data, the name node has to store the metadata for the complete cluster. This starts becoming a bottleneck. Okay. So, uh, okay, there is one question. Do you need to have a node manager on the left side? How will I'll come back to that, Anthony. I'll stay back after the class also. Some questions I can answer that there as well, right? So I'll just move here. So what happened in Hadoop 2.0, and please pay a lot of attention here, right? What happened in Hadoop 2.0 was, I'll not go into all the details, but I'll try to give you a very high level picture. Instead of having a single name node, which is a one single RAM being used, we federated the name node. So there are multiple name nodes which can exist now, which can have their own namespaces. So a namespace means that on a say now you have, say, 8,000, let's assume that you have 8,000 data nodes, right? On each data node there can be multiple namespaces which may be related to the Hadoop cluster, okay, to the name node. So one name node can access, say, namespace 1 on this, namespace 1 on this, namespace 1 on this. Name node 2, the federated name node 2 can handle name node 2 here, 2 here, 2 here. Now the reason why we're doing this is, and this is and we could as well create multiple clusters, right? But then the reason why we're doing this is that though you can store, you cannot run all the data, the name node cannot manage all the data together, but then your processing power of all these data nodes, if you have a 8,000 node cluster, and if you want to run a job on all of them, you can utilize the processing power still. If you had divided it into multiple clusters, you just had the processing power of those 4,000 nodes. In this case, though they are sitting, the one name node can access only one part of the data node, which is one namespace, you can still use the complete processing power of 8,000 data nodes. Obviously, when all of them are working together, it becomes, and parallelly that it becomes as good as having 3 clusters. But then that's not usually the case. There will be cases where, say, you are running, say you may have a customer data in one place, you may have accounts data in some other federation or a namespace, and you may not be running all things together. So if you're running all of them together, if you're running one, then though you can use, say, 8,000 nodes, the processing power of 8,000 nodes, still the metadata which this guy has to store is only of the namespace which is here. Let's first understand where is the bottleneck. Why did we need a such structure like this? Why did we need architecture like this? So your metadata, and you'll have to give me a yes after every question I ask you, so that I know what all you have understood. So everyone understands that the metadata is stored in the name node. For all the data nodes, the metadata, which is the directory structure, where is what place, is stored in the name node. Can everyone give me a yes on this? Yes. Okay. So the metadata is stored in the name node, which means the directory structure, where a particular name node is there, what all data nodes are active, all that data, what all are failing, is stored in the name node, right? So that is clear, right? Now, when your number of data nodes exceeds a certain amount, which this architecture comes into play in very, very large clusters beyond say 4,000 nodes, all this data is stored in the RAM of the name node. Okay, all this metadata is stored in the RAM of the name node. So basically, so now for say when this cluster size goes beyond say 4,000 5,000 nodes, the bottleneck starts coming on the RAM of that name node itself. Okay, and you cannot increase the RAM beyond a certain point, right? So that is the challenge, right? Is that understood by everyone? The challenge is understood by everyone. So instead of having a single place to store the metadata, but so one answer could be, let's create multiple clusters. Let's create 3 clusters of 4,000 nodes, right? And each name node has the metadata of 4,000 nodes, right? That's one way of doing it. Is that right? Can I get a yes? And the next is the answer which I'm going to give you. Is that clear, guys? Great. But then there are many times when one of your cluster will be not doing anything at all, right? And you will be able to use the processing power of only 4,000 nodes if you are using one cluster, right? If you are separating it into different clusters, because two clusters cannot do interaction together. So if we divide this thing into 3 clusters, then there is a chance that when one cluster is free, and you can, when you're running your processing, you can use only 4,000 machine powers, right? You cannot use 12,000 machines together to run a job, right? You cannot make it fast, right? So that's the challenge. Okay, now, so what is the midway? If, let's assume, if we could do this, that we could have a federated structure in which I can use the all the 12,000 nodes for processing, right? Right? And the data, while not compromising on the name nodes capability of storing the metadata. If that is possible, is that not the best solution? Where, say for example, if I have to run a large job, I would, and if there is no other work being done on the side, other clusters, I could use all the 12,000 machines and do it 3 times faster, right? Is that not the best possible solution? Is that not the solution you'll want to know? So the solution to that is, instead of creating separate clusters, you divide your each data node into namespaces, where each data node has multiple namespaces, right? Where each namespace metadata is handled by one of the name nodes. So this name node and this name node and this name node, assuming that there are 3 of them, on this data node, there are 3 namespaces. Each namespace's data will be managed by, metadata will be managed by one of these. Okay, so the advantage it gives is, though the total data stored under one namespace is same, or one name node is same, but then, because we anyways distributed it, but then when I'm running the job, my name node is utilizing the power of all these 3 data nodes, or all the 12,000 data nodes, right? How does SDFS Federation help SDFS scale horizontally? Right. Now, this is the question which I wanted you to answer properly, so that Annie is happy with my performance. Reduce the load on a single name node by using multiple independent name node to manage individual part of the file system namespace. Right. Provide cross data center non-local support for HDFS, allowing a cluster administrator to split the block storage outside a local cluster. I think it's very simple now. The answer is, read this answer very carefully. You'll understand whatever you've learned earlier. Reduce the load on any single name node by using multiple independent name nodes to manage individual parts of the file system namespaces. So you divide your file system into multiple namespaces and let one name node manage that. So that's how it is able to do it. Right. So that's what it says. But the fact that these name nodes cannot talk to each other, they don't require any coordination with each other. They are independent federated. Okay, that's another important thing to note. Okay, another question. You've configured 2 name nodes to manage marketing and slash finance respectively. What will happen if you try to put a file in slash accounting directory? What it's trying to say is that you've created 2 namespaces with 2 name nodes configured, which has one as the marketing and one is the finance data. what happens if you try to put a file in accounting directory through HDFS? Anyone? Anyone who can answer this? What can happen? Will it be possible or not? Okay, good. So yes, now by default it is not possible. You'll have to create another accounting namespace and map it to any of these, or create a new name node. Is that clear to everyone? Yes, error to, or to create a new name node, right? Exactly. So yes. Now another thing which where we talked about the active name node and the standby name node. So this is how it works. There's a client, there's an active name node, there's a standby name node, and there are these shared edit logs where this guy keeps on writing and this guy keeps on reading. In case of a failover, this guy takes over, right? And whenever there's a failover, this guy starts interacting with it. So so this is how with the new 2.x we are able to maintain high availability. Okay, great. So then comes the resource manager, where you have the container and the app master, and then underlying data node. So resource manager manages the resources. We've discussed this also in detail, just a reiteration. The container actually contains the job, and the app master actually looks at that particular how that job is getting executed. More on this in the next few classes, but for now you can understand it this way, that the resource manager interacts with the node manager, and that's how it is able to. So now because of this container and the app master structure, you can run any type of load, which means any type of job on yarn. Earlier it was only MapReduce. So in this case the container is the MapReduce container, and it can run the job there. Okay, is that clear, guys? How does this work? So again, well, this answer, HDFS high availability, or HA, was developed to overcome the following disadvantage of Hadoop 1.0. I'm sure everyone can answer that question for me. Can I get a ABC answer? Can everyone give me an answer ABC? Very good. So all of you have understood that. Very good. The answer is A. Thank you very much. Really appreciate your participation here. Okay, now I think we are done with the architecture, whatever we wanted to cover in this class. Just an introduction on what all are the other type of jobs which can be run on Hadoop, right? So that's where how does yarn take care. So this is again another view of the same thing. SDFS is for the redundant reliable storage. Why do we call it redundant? Can anyone answer that question, please? Why do we call it redundant? Because we replicate the data into multiple places. So we have built-in redundancy here. So in case there are failures which can be managed, and that is why it becomes reliable storage, right? Is that okay? Right, because it has 3 copies. Very good, very good, very good. Amazing. Now yarn is the cluster resource management. We've seen that as well. On top of this, you can run multiple type of jobs, right? So if you're running a batch job, one of the ways of running a batch job is your MapReduce. Okay, so MapReduce is a framework which can be run on top of Hadoop. Now in the Hadoop 1.0, you could only run one type of jobs. That's why Hadoop was restricted by the type of applications it can process. Now you can run interactive, which means text. Means I log in into it and I can do a text. I can run queries on it directly. HBase is online, so that's where HBase comes in. You can actually run online, which means you can query the HDFS table structure as well when you've created a table structure in HBase. Streaming is Storm, which means real time. If you have data coming in real time, say for example, the one application of Storm is in Twitter trends, right? So in fact, Storm was developed by Twitter. So how many have you seen, right? Trending tweets. How many have you seen that? Of you have seen that? Yes, Apache Kafka also can run over Hadoop, right, for logging. That's right. How many answer this question, right? Everyone knows about tweets, the trending tweets. So Storm is the underlying tool, which technology which was developed by Twitter and they later on given to Apache, which does that. So it can do real-time analysis on it can give real-time results, right? So that's where Storm comes in. That's why it is used for streaming data. Uh, MapReduce is, now people may ask you, one question people may ask you is, can Hadoop do real-time analysis? Now when we're talking in context of Hadoop 1, which means essentially MapReduce, the answer is no. But when we're talking in terms of yarn, which is Hadoop 2, and then we can do that using a Storm. Okay, you can do graph processing over by using Giraffe, or you have these graph databases as well. Then there is a very hot technology these days, which is Spark. Okay, now this claims, and this is true, I've run it myself, it claims to be it actually can run 100 times faster than your typical MapReduce. Okay, so that's the power of Spark. It is fast being adopted by the industry, and it can do it can be used, it can do yes, the stock trends that can also be done through streaming data, right? And it can do, this is being used very heavily, this is an in-memory database. Okay, so another in-memory, can you give me an example of another in-memory tool, a very popular tool from a large vendor? No, Cassandra is not. HANA. Very good, Vikram. Thank you very much. So HANA is one tool by SAP, which is a in-memory DB. There are many others, but the most popular one are HANA and Spark. Spark being because it is open source, and most of the people actually are adopting it because it can work very well with Hadoop. HANA can also work with Hadoop internally. Okay, but HANA is SAP and a lot of proprietary stuff there. Spark, in Spark you can program using, well, MongoDB is not. MongoDB is not. MongoDB comes in this class, which is HBase, right? It is a NoSQL database. Okay, so in memory, what in memory means is that instead of retrieving the data from the disk, you can store terabytes of data in your memory itself. Okay, so that's where Spark comes in. You can program it in Scala. Scala is another language for uh, which is used here, or you can use Java as well here. You can use multiple, I mean, there are multiple ways of doing this, right? In Hadoop also you can use Java, you can use Python, you can use Ruby, and there's something called Hadoop streaming, using which you can convert everything into the by default MapReduce program. Okay, so that's those are the various things. This is the power. Now quickly recapping, one of the I want to take one use case of Facebook. For this, what Facebook says, and you can find this out. We store copies of internal log and dimension data sources, use it as a source of reporting, analytics, and machine learning, right? So machine learning means which ads to show to you, your friends, which feed should be shown to you. So this is all done by using Hadoop inside, right? So they have a, and this is the old one. It has a 1100 machine cluster with 8,800 cores with 12 petabytes raw storage. Another cluster of 300 machines with this many cores and this raw storage. Each commodity node, which is the data node, has 8 cores and 12 terabyte of storage, right? Heavy usage of both streaming as well as Java APIs. When we talk about streaming here, this means is streaming through Python and Java, right? Java is directly used in MapReduce, and streaming is used when we write programs in Python or say a Ruby, right? They've built in a higher level data warehousing framework, about which I talked about. It's called Hive, where you can actually write uh, queries in a language called Hive SQL, which will be internally converted into MapReduce. And this is largely for people who are not developers but analysts, who want to still do what Hadoop does, but not using, say, your writing MapReduce programs, right? So that's where, and Facebook is a big fan of MySQL, and that's where a lot of their people were SQL experts. That's why they built up this tool called Hive, which is now freely available for everyone to use. Okay, so this is about Facebook use case. I think, yeah, that's it from the architecture point of view. Quickly, let me tell you that how do you create a cluster, right? And how does a Hadoop cluster work? So one is the standalone or a local mode. Everything is running on a single JVM. You, for development people, this is something which can be used, right? It does not have a distributed file system. Then there is something called a pseudo distributed mode. In a local machine itself, you can run multiple daemons. All the daemons will be run. You can actually do multiple nodes as well. And then the final one is a fully distributed mode, which has the Hadoop daemons running on a cluster of machines, right? So that's where that's how it actually works, right? That's the real production environment. Thank you very much, guys. Really appreciate. Bye bye.